Hi ChemBridge, I'm so sorry all my videos have been a little bit delayed. It's been a bit hectic with semester exams and I'm sure you also feel it, but I wanted to make sure I made a video going over the exam for combustion outline. I will be extending the deadline until Wednesday of next week, so you'll have a window to take your exam. This is just depending on your work schedule. You've had semester exams, so I just want to make sure that you're ready for exam for combustion. Stoichiometry I'll be going over in a separate video. This is where we go from grams to grams or grams to moles, and we use mole to mole ratio. So I just want to make sure that we remember mole to mole ratio. This is where you go from one compound or element to another. So it's like when I go from hydrogen to water, I have to use a mole to mole ratio. I'll go more into detail on those in a separate video. Specific heat capacity. So for specific heat capacity, the way that I learned it was the formula Q equals MCAT. Q is enthalpy, which is measured in joules. Mass is in grams. Specific heat capacity is given. The one that they might expect you to know is water. It's a 4.81, I believe. If not, just Google it. And the change in temperature. Remember, the change in temperature is temperature final minus temperature initial. So let's go over a couple of problems. What is the specific heat of a substance that absorbs 2,500 joules when 100 grams of the substance increases in temperature from 10 degrees to 70 degrees? So again, we just want to label what we have. So we know the formula is Q equals MCAT. So the specific heat of the substance absorbs 2,500 joules. So if you remember back here, Q is enthalpy, so it's in joules. So 2,500 is my joules. I'm looking for the mass. I do have the mass right there. It says 100 grams. Specific heat. What is the specific heat? That's what it's asking for. So I don't know this. That's going to be labeled as X. And then the change in temperature, I have temperature final minus temperature initial. So 70 minus 10 to give me 60 degrees. Let me set it up real quick and then we'll solve for the missing value. So again, Q equals MCAT is our formula. So Q is 2,500 joules equals the mass of 100 grams. I don't know my specific heat and the change in temperature was 60 degrees. So again, I want to multiply 100 times 60 first, and then from there I'll move forward. So you just plug it into the calculator. 100 times 60, you should get around 6,000. So I have 2,500 joules equals 6,000 because I multiplied 100 times 60, x. So I want to get x by itself. I'm going to divide by 6,000 because that's the opposite. Whatever I do to one side, I'm going to do to the other side. So I have the value 2,500 divided by 6,000. And it should give me somewhere around 0.42. Again, I rounded up. 0.42 would be my specific heat capacity. So that would be C. For this next one, you can try it on your own. You can pause me and then we can go over the exemplar together. Okay, class, so let's go over this question. If 200 grams of water is heated from 24 degrees to 100 degrees, how much heat must be added? The specific heat of water is there. So again, we use the same process. This is very similar but different. Our formula is Q equals MCAT. So again, I do not have joules here. So this is my X, Q is my X. My mass is 200 grams. My specific heat is 4.18. So close, guys. At the beginning of the video, I think I said 81. And then the change in temperature, here's my temperature final and my temperature initial. So I have 100 degrees minus 24 degrees. And that'll give me my change in temperature. So I have a total of 76 degrees. Again, I just have to plug it in. My formula is Q equals MCAT. So I'm looking for Q, so this makes it a lot easier. My mass is 200 grams. I'm going to multiply that by 4.18 joules per grams per degree Celsius. And my change in temperature was 76 degrees. Again, plug it into the calculator, super simple. And we should be able to get our answer. In joules, this is 63,536. Be very careful with this. We know this is joules. Sometimes they're going to ask for kilojoules. So remember, 1,000 joules equals 1 kilojoule. So we would have to divide this by 1,000. Normally, with large number like this, they will ask you to convert, and we'll be left with 63.54 kilojoules. Again, make sure to pay special attention on how they ask the answer. If it's in joules, it would stay as is. If it's in kilojoules, you have to divide by 1,000. Coal power plants, guys, be very, very familiar with this picture or schematic. You have to know that when the coal is burned, the potential energy within the bonds is broken, and you go to kinetic energy. That steam goes to the turbine, that's kinetic energy, going into mechanical energy. From the turbine to the generator, turbine to generator is mechanical energy. So we did the kinetic energy to mechanical energy. And in the generator, that's where it happens, where electrical energy is produced that we get on our end. Again, rewatch it. Just know from where's the potential to kinetic, kinetic to mechanical, mechanical to electrical. The first law of thermodynamics, guys, is on lesson 39, video 1. Rewatch it. Make sure to add notes and Google some examples. There's going to be like a matching portion where you have to compare first law and second law. The same goes for the second law, video 39. Lesson 39, video 4. Take some notes and Google some examples so you have an idea of what it looks like. Exothermic versus endothermic. I love this one, guys. This is a common misconception always, not just in higher level chemistry, but in my pre-AP chemistry. When bonds are broken, you require energy. You need energy in order for those bonds to break. So it is an endothermic reaction. So an image that can display that is you go from a double bond to a single bond. Bonds were broken, and again, you needed energy for that to happen. Exothermic, when bonds are created, you release energy. I know most people get it confused, but when bonds are created, you have to release energy. So you're going from a single bond to a double bond. That's an exothermic process. So again, when you break bonds, you need energy for that to happen. So that's endothermic. Again, you can look over the slide. But just remember, endothermic is bonds are broken, you require energy, so from a double bond to a single bond. And exothermic is when you create bonds, so from a single bond to a double bond. Efficient energy, guys, just know about different processes that have better energy efficiency, especially for those energy plants. They give different examples of like what would be better alternatives for energy. Calories, I will create a video, but lesson 39, video 3 goes over this. It's just simple dimensional analysis from calories to the smaller calories to kilojoules. Definitions, make sure that you have the definitions for these 4 vocabulary words. You're going to have to match them. Negative of fossil fuel combustion. So again, they talk a lot about how we need alternative forms of energy due to the negative effects of fossil fuels. Specifically, lesson 40, video 2, make a quick list of why we need different energy or alternative forms of energy. E10 compared to octane. So this is ethanol 10 compared to octane. Go back to that video and find the differences of E10 and octane. This, guys, just make sure you remember it. The names, have it handy for the exam. You will have to identify a couple. So we have methane, ethane, propane, butane. From C5 down, it's pretty easy. Pentane, hexane, you're using your Greek prefix in the beginning. Again, alkane is a single bond, alkene is a double bond, and alkyne is a triple bond, carbon to carbon bonds. Do not put an S at the end of the name. When I took the exam, I made that mistake and I was so upset. So just keep it as alkane, alkene, and alkyne. Single, double, triple bond. The effects of catalysts on enthalpy of a reaction. So again, remember when you're adding a catalyst to a reaction, all you're doing is reducing this activation energy. So instead of having to go all the way up here, your activation energy is lower, but your enthalpy remains the same. So enthalpy remains the same. You can watch it again, but I just want to make sure that we understand that enthalpy remains the same. Catalyst just reduces activation energy. Limiting an excess reactants, I'll make sure to create an extra video of this. It's stoichiometry again, but you're finding which one limits you. So let's say that I have, I'm trying to make milkshakes or strawberry shakes, right? And I tell you that for each sorry guys, that's supposed to be a milk carton. And I tell you that for each milkshake, you need 1 milk and 1 strawberry. So I can make 1, 2. My limiting reactant would be the strawberries because it doesn't matter how much excess milk I have. I can only make 2 strawberry milkshakes because I only have 2 strawberries. This is limiting me, right? So it's the same concept, but given in like grams to moles situation. Isomers and knocking lesson 45, videos 2 and 3. Just make sure to go over it. This is essentially everything that is on the exam. I'll be hopefully by this afternoon posting more mini videos going over the math part. But again, take the notes, take advantage of being given like this little guide and use it. It will definitely help you. Happy studying, guys.